In this video, we are going to be looking at the which command in R. The which command is going to allow us to find us the location of variables within an object that take on certain characteristics. So inside of a vector or a data frame or a matrix, we might want to find out, for example, which values are greater than 10 or which ones are even and less than 50, for example. The which command will tell us what are the locations of all of the variables within our object that take on those particular qualities, and then we can figure out what those values are, and we can also apply functions to them afterwards. Now, in order to do this, we need just a quick review first of logical operators in R. Now in R, we're going to have a couple different kinds. So we have some that are going to give directions, and we have some that are going to ask questions. So the first two that we have here, we're going to want to think of them as question asking statements. So the double equal sign is a question to ask, does what appear on both sides of the double equal sign actually equal to one another? So if I had the statement 2 double equal sign 2, it would return a value of true. This question is going to maintain a true or false. If they are equal, we'll get a true. If they are not equal, it will give us a false. We can also ask the question, are these two things not equal to one another? So if I ask whether two things are not equal to one another, like is 2 not equal to 4, well, that would be true. It's not equal. So 2 not equal to 4 would give me true. But if I did 2 not equal to 2, that would give me false. So the true or false is relative to the question that we're asking. Now our other logical operators, we can think of them more as giving commands. So if I want to combine a bunch of different statements, I could look at my and, my or even a negation. So if I wanted two things to be true at the same time, I could have statement, ampersand, statement to ask if both of these things, for example, are true at the exact same time. And it will look piece component wise through our vector. So if I was looking at a vector that had 10 components in it, it would check both the first, second, third, all the way up through 10th. The straight line is our logical OR operator. Now I say logical OR because it's in the sense that we use it in logic and in math. OR means at least one. So if I have statement or statement, it's going to ask, is at least one of these things true? The first statement on its own, or the second statement on its own, or both of them could be true. So it will look for which values of our vector x where at least one of the two statements is going to be true. And then we have our negation. So if I put that exclamation mark in front of a bracketed statement, it will say, I'm looking for the places where this is not true. Now we'll look at some examples of these in action, but this is our quick review of logical operators in R. Now let's pull up RStudio and get to work. Now that we've opened up RStudio, first we're going to make ourselves a vector that we're going to work with, an x vector. Now I'm going to first use the setSeed function so that you can reproduce what I'm doing here. The setSeed will make sure that randomly generated numbers will always generate the same thing. So we'll set seed to 42, and then I'm going to make a vector x that I get by generating random normal variables. I want 10 of them, and I want them to be generated with a mean of 5, a mean of 20, and a standard deviation of 5. And this x is let's print it. So let's run those 3 lines of code, and you'll notice that I have been given 10 numbers that look like they come from a normal distribution with a mean of 20 and a standard deviation of 5. These all look like logical values that I might have gotten for that. Now let's look at some very simple statements. So the easiest thing, which of a single statement, which of our x's, for example, are greater than 20? If I run this line of code, it's going to give me the values 1, 3, 4, 5, 7, and 9. So I'll notice that the value 1 is greater than 20, but the second value is not. The third value, the fourth value, and the fifth value are greater than 20, but the 6 is not. And we'll notice the same thing with the 7th and 9th are greater than 20, but the 8th and 10th are not. So again, it didn't give us the values which are greater than 20. It gave us the position of the x's that are greater than 20. So that's our simplest type of which statement. Let's look at something with logical operators. I could look at something with an or statement. So I want values which either this first statement is true or the second. And logical or means both of them could be true. That won't happen here. I can't have a number that's greater than 24 and less than 20 at the same time. But in a different situation, it might be possible that both could be true. So let's run this line of code here. So I want to look for values which are greater than 20 or 24 or less than 20. So 1 and 2. 1 is greater than 24, so that's true. 2 was less than 20, so that was true. Now notice the next value is 6. So 3, 4, 5 were not true. 21 is not less than 20, and it's not greater than 24, so it didn't count. Same with 4 and 5. And all the rest of these are either less than 20 or greater than 24. So we have the numbers 6 through 10, which are going to count. Now, the next statement, let's look at an and. So this is a slightly more spicy function just for us to look at it. Now, we need to explain two functions here for you. So the first one is going to be the floor command. So the floor command is going to give me the x that is the next integer below my actual number. So 26.854, the floor is 26. 17.17651, the floor is 17. Didn't matter that this one would round to 27 and this one would round to 17. I'm always taking the integer below. This function here says modulo function. So it's saying mod 2 if every number went through a cycle of how many is left over when I divide by 2. So for example, 1 mod 2 would be 1, 2 mod 2 would be 0 because I have no remainder. 3, I have a 2 that goes into it, then I have a leftover 1, so 3 mod 2 would be 1. 4 mod 2, I have a 2 plus 2 makes 4, so there's nothing left over. It would have a mod 2 of 0. So let's just run this little bit of our code here. And we'll notice that what this is basically telling us is whether we had even or odd numbers. Anything that was an even number gives a 0 because it's divisible by 2. Anything that's an odd number gives us a 1 because it's 1 more than a multiple of 2. So if I ask which of my x's have a floor mod 2 that is equal to 1, I'm asking if I look at the integer part, which ones of these have an odd value? The floor mod 2 is equal to 1. So let's run that line. And we're going to see which of our values of x's had an odd number. 2, 3, 4, not 5, 6, 7, 8, not 9, and 10, exactly as we want. Now we can get, again, even spicier. Let's combine some interesting things. Maybe I want to know which are greater than 20 and the floor mod 2 is equal to 1. So I put this statement in brackets, and then I put this statement in brackets. I need both of them to be true. I need the integer part to be odd, and I also need that the value of x itself is greater than 2. So when we run this, let's just remind ourselves here what the x looked like. This was greater than 20, but the integer part was not odd. This was not greater than 20. This value was greater than 20, and the integer part is odd, so look, 3 is one of the values. 4 should be a value. So this, the integer part, is odd, and it's greater than 20. Then we'll go through them, and they will all fail except our 7th one, where the integer part is odd and the number is greater than 20. So if I'm looking at ands, I want to see where both statements are going to be true at the exact same time. Now that's great. I know the location of these values, but oftentimes what I really am interested in is the value itself and not the location of the value. So if I want to find my actual entries, I'm going to remember that in R, we use the square brackets as kind of a locator function. If I, for example, put x and I put as a locator of 1, it will say, what's my x value for the first position? X square bracket 9. What's my x in the 9th position? That would be my value here, 30.09212. If I want x's in the positions 1 through 3, that will give me the first 3. So if I know that I have a particular set of values, I can add that which function inside of the square brackets. So it's going to say, locate me all the values for which this is going to be true. So let's look at this interesting one right here. So I'm just going to build this statement up for you. So this is going to be a statement that says, which of my x's are not less than 23. So remember, if I had which x less than 23, that would give me my x's less than 23. If I have which with the exclamation mark, that's going to give me a not. So let's just build this up for a second. Let's see how this would work. Which x's are less than 23? So we'll look at the ones less than 23. For example, 2 and 3 are less than 23, but the fourth one, 23, is not. Now if I go which of not x less than 23, I'm going to get the opposite ones. Less than 23 were 2, 3, 5, 6, 8, 10, which were not less than 23, 1, 4, 7, 9. Then I'm going to say, let's locate the values of the things in this position. So now I'm getting all of the values which are not less than 23. Not the locations, but the actual values. 26, 23.16, 27, 30. All of these numbers are going to be my x's in my vector that were not less than 23. Then I can take this a step further and add a function. So if I want to know the average of all the x's, I just add another thing onto my equation here. I want the average of all the x's which are greater than 23. So we see we're building things up a little bit by little bit. First, we ask ourselves, where are things located? And then we use our square brackets to find the values at those locations. And then if we want, we can further add on to a functions. And that is how we are going to use our